Do you know what's expensive? Anyone? Great.
Everything.
Logs. Logs are extremely expensive. And why is that? Because they charge you twice. First, to ingest them, and then again, to store them. And that's before I add cross-region traffic, network egress, or the bill for storing months of logs that you will never open. And because of this, we're constantly looking for ways to save cost. Wait. Looking for ways to save cost. So maybe you're sending some retention policy and deleting the rest. But what if you suddenly get a ticket about an incident from 2 weeks ago and you've just deleted all of the relevant logs? What now? So maybe you're putting some retention policy or using some sort of an archive, but which results in lack in performance because when the support engineers need the logs, because the customers are angry now, they don't have 5 hours to wait for AWS to retrieve them from Glacier. So, what now? What's the solution? How do we keep cost low, performance high, and customers happy? That was the exact dilemma we faced at Kaltura. My name is Ido Ziv. I'm from Kaltura in Tel Aviv, and I manage a team of DevOps engineers that's responsible for all the shared infrastructure across all Kaltura's applications. What you need to know about Kaltura is that it's an AI-infused video company. And what is a video company? Means lots of network and lots of storage. And that means lots and lots of logs. So the reason I'm here today is I'm tired of being woken up in the middle of the night regarding service escalations. I would get a call from a support engineer stating, "Hi, Ido, sorry to wake you up. We have an escalation with a customer, and I'm trying to find the logs in the observability system, and I just can't find them. Can you please help me?" So now, after I hang up on the support engineer, I need to go and wake up someone else on my team and tell them, "Hi, can you please pull the necessary data from the archive? The support engineer needs them now. Thank you." And that was my life. And to make the bottleneck even worse, once a month, my team would receive a ticket stating, "We can't correlate between the logs of application A and application B. Please fix." But as you know, different applications has different requirements. So every time we wanted to make a change with our previous provider, it was a paid implementation. And that's where the FinOps come in. And every once in a while, I was in a FinOps call, and I was asked, how do we reduce observability cost? We are paying too much. And honestly, they weren't wrong. We were paying too much. And we were spending money and engineering time on a system we didn't create, and a system that slowed us down instead of helping us push forward. So we made a brave decision to migrate out of the observability system. It was a SaaS provider we used because of high costs that weren't in the budget. All the time invested in this supporting observability just didn't make sense. I was focused on producing excuses or clever ways to measure this supporting the support kind of a project instead of focusing on our roadmap and innovation. And so that's why when the contract of the SaaS solution was approaching its end, we decided not to continue with them. And we started exploring other options. Options like another SaaS provider, which is great, Amazon CloudWatch or any other cloud provider native observability system, or go DIY. So let's try to compare the ups and downs of each option. First, we'll go with the SaaS. SaaS is the easy bit, it's quick deployment. We get out-of-the-box features, reduced maintenance, and we get plenty of support. All the support that one can ask for, SaaS will give you. But they come with a price. I mean, literally price. You get high long-term cost. You get vendor lock. You get compliance risk. And of course, there are feature gaps that force you into support tickets whenever you need something. So SaaS gives you convenience, but you pay for it in dollars, in man-hours, and honestly, in flexibility and control. And for our solution, due to a huge amount of logs, it just didn't make sense. Next up, we have CloudWatch. CloudWatch is also great. You get seamless AWS integration. It's a fully managed, pay-as-you-go, ta-ta-ti, ta-ta-ta. You know, Amazon takes care of everything. But at our scale, costs skyrocket. You're tied into the AWS ecosystem. You have long retention cost. And, of course, the UI is painful, and the query performance is not winning any awards. So CloudWatch is great for small and medium workloads, but for our scale, it just didn't cut it. And then we have the DIY option. DIY option is also nice. It's cost-effective. You have full control over your data. You can deploy it everywhere, even multi-cloud. But the problem is that you have full control. And you also inherit everything else. You inherit the engineering overhead, the skill requirements. You don't have any support. You have reliability risks. So DIY gives you responsibility. And you get freedom, but you also get the responsibility that comes with it. So with a collective relationship with AWS OpenSearch team, you can also expedite some great features. So now let's try to compare all the options I just showed you. But instead of using some sort of boring cost performance chart, I've decided to go with like real-world parameters. Things like agony for contacting support, the amount of developer complaints I get about query performance, time to actually return to the roadmap, and of course, marriage with the vendor. So I hope you're ready. Let's begin. Oh, shit. So regarding contacting the support experience, both SaaS and CloudWatch will get 4 stars. You have premium support. You can open a case, but waiting for the engineer to read your case notes at 3 a.m., well, that is horrible. And when you go DIY, you don't have support. If you need something and the system is broken, you need to talk to the DevOps. And talking to the DevOps means bribing the DevOps. And actually, nobody likes them. So what about query performance? Here, SaaS and DIY is the great option. You have great customizations, solid performance. I'll give them 5 stars. And CloudWatch, let's be honest, the UI is painful, and if we choose this option, the backend team will never stop yapping about it. Now, let's go to time to market. With SaaS, you get quick deployments. You have all these docs and stuff. It's like click, click, next. It's the easy solution. And CloudWatch is also good, because all you need to do is understand IAM policies, which is, yes. And last but not least, let's go with the DIY. The DIY gets 3 stars, because you're writing everything yourself. So goodbye for other tasks for a while. And the last category is marriage with the vendor. So SaaS is basically Vegas. It's easy to get in, it's impossible to get out. And if you use CloudWatch, you're chained to the AWS ecosystem. And when you go DIY, you have all the options open. And now, after we compared, we try to estimate the engineering cost of these solutions. So when we go DIY, we probably will need 50 liters of coffee every day. We'll get 20 tickets for standing desk from IT every month. And we'll get 2 more weekly meetings. Who doesn't like weekly meetings, huh? I know I like them. So that's what, and after all the comparing and calculating, we realized we need to go DIY. That is the right approach for us. The cost is in our budget, and the team is ready to make the decisions and gain the skills needed in order to build the DIY. And with the correct relationship with the AWS OpenSearch team, we got confidence in using OpenSearch for our highly scaled observability. So now we only have one more decision to make, whether we're going to be DIY from scratch, or we will use a managed service. And you probably run into this before. Our goal as engineers is to bring value to our companies. And spending time on maintenance tasks that we can easily outsource doesn't necessarily bring value to my company. And whenever there is a security patch, I'd much rather have my cloud provider, AWS, patch it for me instead of me going and SSHing into machines. It's way easier. So that's where a managed service comes into picture. With managed services, you get out-of-the-box features, native integration that follows class best practices, and of course, the cherry on top, you get premium support the thing that was missing with the DIY, here you get it. You can always count on your cloud provider to have your back with common, straightforward tasks, leaving you the actual decisions to make. So we chose sorry, I'm excited. The best of both worlds. Nice. So what do you need when you will go DIY? First of all, you need time. And time doesn't necessarily mean time for building the system. You also need time to support the system. Because whenever the system will be down, your engineers will treat it like any other production environment down. They will stop everything and go to fix it. And the next thing you need is a deadline. We need to bring in together all the stakeholders and define the requirements we need. We need to think who from the team should be involved in the project and who doesn't. And also, as you know, DevSecOps, they want to shift left, and that means you need to bring the security architect from day one. But scheduling with the security architect, that can take up to 2 weeks in my company. And the last thing you need is skill. Because when you use some sort of a vendor, like a SaaS or a cloud managed, you have the skills coming from them. But when you go DIY, you need to bring in the skills yourself. So you need to evaluate if you need some sort of a research or maybe training or consulting with an external company like external consultants. And once we decided to go with the managed version, we had to align our internal team to set the expectations of what is needed from each team before we start migrating. And why is that? Because, oh my God, because managers hate migrations. So we had to make the migration as quick and as safe as possible. I didn't want to go on calls in the middle of the night explaining my managers, oh no, the system is down because we forgot. No. We had to make it as quick and as safe as possible. And also, we had to get a mutual handshake between all the different teams. Like every team will define the requirements, and we will define the parity when starting working on the new project. Starting from the most simple features and going into the most important feature for us, which was increasing the retention for the most important logs. So, once we decided that we will build it and start tackle it, let's see the Kaltura in numbers. Okay, now we're good. So, Kaltura deploys over 200 different applications across 6 active cloud regions. And we are ingesting 8 terabytes of logs every single day. And there are some days where the numbers get even scarier when we reach 6 gigabytes of logs every second. So, with that huge amount of data, we had to create a plan. Let me introduce you to the plan. So first of all, we said, let's research the ingest, because we had 8 terabytes of logs to ingest every day. But then we need to store them, so let's research on the storage. But I started with saying logs are expensive, so maybe we'll try to save some cost on the way. And we have the security architect, so we'll secure the gates. And then, in the end of this treasure map, we'll reach the smart retention, which is the reason I'm here today. So we will start with the research. It's always good to start with the research. We'll focus on the ingest and the storage, and then we'll reach the smart retention. So after getting our readings done and seeing some YouTube videos, we've decided that we need proper research to handle the high volume of ingested logs. And we also don't need how to keep those logs after we ingest them. So we played around with dev environments and labs, and we got into contact with the external company. You can scan their QR right there. They're called Big Data Boutique, and they helped us a lot. So they helped us bring the project into life. And we started learning about OpenSearch best practices. You can scan the docs here for the documentation and see. I will focus on the right column, the JVM usage and the disk usage. So we had to plan the OpenSearch from scratch. And we said, OK, you must use 85% or less JVM usage on your machines, and we have to keep the disk usage below 80%. Honestly, this gave me a headache. I was like, OK. What now? What do I need to do now? Research. Always do your research. While doing my research, I was getting my hands dirty and started learning about industry standards, such as data streams, ultra-warm nodes, and index state managements. Those are features presented by the OpenSearch to help you keep the logs organized and managed for you. And before I show you the diagrams and the design, let's break it down into steps, the said research. We started with Data Prepper. Data Prepper is our solution for ingesting the large amount of data we do every day. Data Prepper is the open source solution, and AWS offers AWS OpenSearch ingestion, which gives you the managed service and the auto-scaling that comes with the service. So it can handle the spikes that we need, which is great for our 6 GB spikes. And also, you can ingest from multiple sources, such as traces, logs, metrics, and yesterday I learned that you can combine them into one. That was amazing, thank you. And also, Data Prepper allows you to read from archive, which is a great fit for us, for my use case. So, using the archive reading ability, we can also rehydrate data from S3, meaning that this is a life changer for the support engineers. And from the support engineer in the beginning of this lecture that called me, now he can re-ingest the data he needs himself, which is awesome. But what about storing the data and the data lifecycle? Sorry? Okay. We need to research on the disk size. And there are two options. We can use less nodes with greater disks, but then we might hit query performance, and then the developers will start complaining, and then we're not winning anything. And also, we can use more nodes, but with less disks. And that's the problem where we are not so cost-friendly because we're paying for more nodes. So what's the solution? What's in between? How do we overcome it? Let's do some math, OK? Let's say I have 100 of gigabytes of data I need to ingest. So that means I probably need 100 gigabytes of disk, right? Wrong. We need to keep space for indexing overhead. And that's it? Wrong. We also need, we are using Linux, so we also need 5% for the storage and the boot volume. And that's it? Did we finish? Of course, you can guess. Wrong. We also need OpenSearch service overhead. So if I have 100 gigabytes of logs, I will need minimum of 145 gigabytes of disks. And you can also see the nice formula I've attached below, which means that we need to take into account the number of replicas of the data we need. I'll let you sink in the math for a second. When calculating the disk size with OpenSearch, we need to consider the shard count and the replica count for each index. As you can see in the formula, replica count is a great factor in the disk size. Now that we understand that if we want to control the replica size, our plan will fail. So we planned. We have this microservice template repository, and I've added some settings to it. We said we'll go with 0 replicas for all of our indexes, because this is logs, and worst case, we're losing them or pulling from the archive. And we will use 1 shard. This way, we can be more dense and manage the cluster the way we want. But some indexes are large, and they have lots of data. So for them, we had to give them like the special treatment. And after playing with the labs and dev environments, we learned about NVMe SSD. I know I said a lot of words. Let me explain what I just said. The NVMe SSD is a type of disks that is the type of node, that OpenSearch uses to not use an EBS volume, meaning that you don't have EBS volumes attached, so no EBS latency and no EBS bottlenecks. We can use smaller clusters with less nodes with greater disks. Isn't that what we wanted? So smaller cluster for the same workload. OK, so the final piece of the research and the data is actually bringing in the data. So we had to play around with shippers. So we collected metrics, traces, and logs from the system. Started with logs, we integrated FluentBit into our data. And while we are using Kubernetes, I didn't want to create a daemon set overhead, meaning that we can use FluentBit for logs, and we can also use Prometheus node exporter for metrics. And then I have 2 daemon sets. But I also have traces, and I don't want to create a trace daemon set overhead. So what can I do? Now, a year after the project, I can tell you that FluentBit supports both metrics and logs. But at the time, it didn't. So we had to use 2 daemon sets. But what about the traces I just told you? So for traces, we used oTel collector. I see you're surprised. Yes, oTel collector. It's great. It's the best option. And not all the developers know or want to use traces. So only the developers that needed this feature, the traces, got it. So no daemon set overhead, which is great. This is why I'm here. And now, let's take an example. Let's take a look on the data lifecycle. This is heavy. So let's digest it for a second. The second part of the research is to make the system robust and self-healing. The last thing I wanted to do is to get calls in the middle of the night about disk pressure in OpenSearch. And nevertheless, I didn't want to get more tickets about missing logs in Jira. This also doesn't a thing that I didn't want. So we had to create a plan. This is where the ISM templates I mentioned before come into picture, and also the ultra-warm nodes. We can use ISM to move indexes between tiers and extend the retention for indexes. Once again, we're paying less for more data. And once the data reaches OpenSearch, through data prepper, it will go to the hot nodes. And the question is, when will it depart from said hot nodes? So to the ultra-warm, and then the cold, and then the delete. So we had to ask ourselves a question. Will the support engineers need those logs? Will the devs need these logs in 2 days? If the answer was no, then we can ship the data into ultra-warm, if then after a few hours. But if the answer was yes, then we need to take into account the index sizes and the shard counts. That's where things get more complicated. And traces is a great example, because we decided that traces will be real-time data only. So let's say I'm a developer and I want to optimize the system using traces. I will use the real-time data, or in the worst case, I will pull the data from the ultra-warm. I won't keep the traces logs for more than a day, which is great. But now I want to show you the magic of ultra-warm in numbers, in money. Okay? So think about stepping down the timeline. When we go to the OSIS or the hot nodes, we're paying $1 per $1. This is like the baseline. But when I move the logs to the ultra-warm, see the magic. I'm paying 10 to 15%, 10 to 15 cents on the same amount of data. So we're saving about 90% of the cost for the same logs. And now we want to ship the data to the cold nodes. And what does it mean from the cost perspective? We're paying 5 to 10 cents on the same data that we paid $1 in the hot nodes. And you're probably wondering what the delete is. The delete is where the logs are shipped to the farm up north. And now, after all the research and development was done, we had to sprinkle some security on top. And we started small with features like SAML integration to use our own RDP, or encryption. We used KMS and ACM for encryption and transit and at rest. But these all are for humans. What about automation or MCP servers? How do we grant them access? So OpenSearch has a native role-based access control, RBAC system, that allows us to map roles and identities to services that can act against the cluster. And the security plugin of said OpenSearch allows us to map these roles to external identities, such as IAM roles or SAML entities. And this is amazing, because now granting full access to automation role is just being lazy. And also, when we use the tenants, we can separate between the different roles of the company, meaning everyone can read logs by default, but creating dashboards, visualizations, queries, each team will create their own. And they won't overlap. They won't step on each other's toes. So now that the research is done and we got a working POC with security on day one, we are ready to start ingesting, throwing some traces, logs, and metrics into the span. We got one-stop shop observability. Woo! So let's review what I just told you. We started with the research, and then we combined some signals. We defined the data lifecycle and when will it depart, and we baked in security from day one. Great. Our plan is working. But we didn't just build a DIY. we also gain the knowledge and skills to manage it on our own. So let's see some diagrams, shall we? And we'll start from the part that everyone actually cares about, the dashboards. As you can see, users, developers, operators, etc., can access the OpenSearch dashboards. There they can find traces, metrics, logs, and let's be honest, they can complain. They can complain about the query speed, which is great. As you can see, we're using the private VPC of the observability VPC. I don't trust the internet, and the internet don't trust me. We are using our own lanes where the logs are being kept safe and secured. The biggest takeaway, developers and operators get a self-service way to debug and troubleshoot issues with security guardrails baked in. Now, we will zoom out a bit and see the next phase. Observability isn't much fun without things to observe. So now we'll take a look at our two compute accounts. On compute account A, compute account A is using a Kubernetes cluster. We're running on EKS. And the EKS offers two sidekicks, a log shipper and a traces shipper. All their job is to nag OpenSearch with data 24/7 using SADOSys. And in compute account B, down on the left, we can see a good old EC2 fleet. And the EC2 fleet also has a log shipper and a traces shipper, who also nags OpenSearch with data 24/7. Think of it like a club bouncer. If you don't ship in metrics and logs, you're not getting in. And now it's time to pop up the hood. I'll let you take a look for a second. At the heart of the observability account, we have, guess what? OpenSearch. You can see that we deployed it over 2 availability zones because nothing says serious architecture like dotted blue boxes. And then we can see the cluster administrator nodes. Cluster administrator nodes, the master nodes that are keeping things organized. Then we have the data nodes and the ultra warm nodes. The data nodes are where the queries happens, and the ultra warms is where your logs go to retire. Sort of like putting your logs into Florida. And then on the right, we can see, on the right, you'll notice AWS integrations with services such as IAM, KMS, SNS, etc. It's AWS way of saying we're watching you, but in a good way. And now that we saw the architecture and the design, let's see the results in action. We begin with traces. Here we can pinpoint which API calls or services are slowing down the system. Notice the latency variance is the third column from the left. We can see some of the calls are blazing fast and others not so much. And then we can see the traces per API call per group. We can see the duration, the percentile, very cool. And we can also see the spans. We take each trace and we break it down into smaller actions. Here we can see how long each action took. Like contacting the database, you can see it's 56 milliseconds, how long the middleware took. This is how the developers can optimize the code. And if you don't want to use the timeline view, you can use a table view. Great. Everything is about the spans. And now let's place those traces into context. The service maps that you can see here shows us the different services we use in Kaltura. The auth broker, the user profile, and the app registry. They show us how they interact. The spike in that we saw earlier, using the service map, we can see the dependency chain. And also we can see the throughput rate and the error count using the same system. And we can also correlate the two views. We not only see the slow request, we understand its impact on upstream and downstream services. In other words, traces tells us what is slow, and the map shows us where it actually is slow. So let's talk about the results. The amount of tickets that we got dropped significantly, and the cost dropped too by up to 60%. That's amazing. The devs and support start asking for new features. We got early adopters in-house. We're finally able to show some results in numbers. with observability costs dropping by up to 60% from the SaaS rate. You should have seen the FinOps phase. By centralizing our observability system, we are not only able to correlate between signals from multiple applications in one dashboard, we can also use one dashboard, and we don't need to open multiple browser tabs or multiple observability tools. And that event is not the biggest achievement. Let's see the early adopters, what they're saying about the system. And one of our architects. And what about the VP R&D? Reading logs in OpenSearch is like Netflix. Endless scrolling, but at least the errors are original content. Thank you, Alon. It was a great comment. And are you ready to see the holy grail, the cherry on top? We got smart retention. With longer retention for the most important logs, going over 30 days for the logs that matter. And for the logs that don't matter, well, we ship them even after a few hours to the rest of the system, the ultra warm and such. Really cool, huh? So I told you a lot of stuff. Let's do a bit of summary. We started by me coming here telling you logs are expensive. And then we did some comparison. We compared the DIY to the SaaS to the managed version. And then we conducted a research, because research is important, always do your research. And then we built the architecture. We started ingesting traces, metrics, logs, and such. And we said, hey, observability is fun. Let's continue using that. And we delivered results. All this beautiful presentation was presented over 3 months of a project. So even you can do it in your own company. So what I want you to take from this lecture. First of all, keep in mind that you're working for a business. And the goal for the business is to make profit. Tech debt can pile up. And being a great engineer means coming up with clever ways or ideas to reduce the tech debt while delivering value to the business. And also, when you're building a POC like I did, remember, POC is quick and dirty by design. No GitOps, no AC, nothing. Go to the console, do click, click next, and finish with the POC. It's important. Don't waste time. And if you're thinking about doing something similar, you'll find resources that help you. 1 second. And before getting into the shiny tech stuff and starting piling up tickets, first make sure that you know the requirements from the team. And you can deliver the key KPIs for you. There are some great trainings in AWS well-architected labs that will help you. And you can see them. Here is a link for the labs with AWS well-architected labs. And on the left, you can see my blog, co-written with AWS, where I examined the story I just told you today, and also added live code snippets where you can copy and paste, much like Stack Overflow. Isn't it great? I did the work for you. So next time you find yourself staring at especially large log bill, remember, it's not about deleting everything, and it's not about hoarding everything either. It's about planning smart retention, because logs serves you, and not the other way around, because logs don't have to be the enemy. Thank you very much. Oh, fuck. Thank you very much. Add me on LinkedIn. Bye-bye. Okay. I'll repeat the question. Let me make sure I understand it. Did I examine the Netflix use case where they only examine part of the traces, the one that they actually want? So yes, we did saw that, and we're also trying to adopt as much as great technology we want. But we weren't in the phase where we can actually do it, because it's a very complex situation. It's Netflix use case. Oh, yeah. My use case is a bit different, and the fact that I was bringing traces to the mix and enabling him for every developer that wanted, was the first step. Now, in the next steps of the project, we can also start implementing features like you said.
One more thing. You actually compute the gigabyte, 5 gigabyte plus 5% of the 100 gigabit example as a percentage. But if you actually want to approximate it as a constant, so it would be more about 140 versus 145 implied.
140?
Rule of thumb, yeah.
Okay, so there are great, I'll repeat the question. Again, he said about the formula I presented in the presentation about the log multiplier. Instead of 145, we should use 140. And my answer to you is I took the formula from the AWS documentation. There are some great AWS engineers here, so go ask them. I just copy stuff.
I actually work that I'll do that.
Okay,
Thank you.
do it. Any other questions, maybe?
Awesome.
Thank you. Okay, now I'll turn off the mic. Thank you.